Okay, well, good morning. Happy Friday. We finally made it to Friday. Go ahead, take out your bell work and try to factor. We're only doing that first question, not the second one. And pick up a copy of today's notes. It's just one page, 6 examples that we're going to cover. So I'll give you a second to find this question. 2x squared plus 9x plus 4. Try to factor it down, and then we'll go through it together. So A is not 1, A is 2, B is 9, and C is 4. So we need to make our box. Whenever A is not 1, we need to create our box. A always goes in the top left square. B is going to go in the bottom right square. Not B, sorry, C. C goes in the bottom right square. So A and C. Now we need to do our puzzle. 2 numbers that multiply to be 2 times 4. So A times C is 8. Then they add to 9. Don't say it out loud. Give everybody a chance to think of those numbers. They multiply to be 8 and add to 9. So I'll give you all a second to think about it. All right, what would those numbers be? 8 and 1. 8 times 1 is 8. 8 plus 1 is 9. So we're going to put our 8x and our 1x in the other 2 squares. And then let's go 2 squares at a time and take out our greatest common factor. So if I look at these two, the 2x and the 8x, 2x squared and 8x, they have a greatest common factor of 2x. 1x and 4 has a greatest common factor of 1. 2x squared and 1x has a greatest common factor of x. 8x and 4 has a greatest common factor of 4. So your factors, because it did not ask us to solve it, it said factor it. So my first factor is x plus 4. And my second factor is 2x plus 1. And this would be your final answer. Who had that for the bell work? Good job. All right, let's look at our notes for today. So today we're focusing on factoring, a special factoring pattern, and that's called factoring the difference of perfect squares. And it happens when you are subtracting. So in that first blank, write subtracting. And it's 2 perfect squares. So for example 5, it says factor a difference of perfect squares, and it is asking us to solve it. So let's go ahead and write down example 1, or let's look at example 1. Now remember, the first step of factoring is set it equal to 0. We're still going to set it equal to 0. So that doesn't change. Step number 2 is look for a greatest common factor. We don't have a greatest common factor. Step number 3 is check to make sure we have all of the rules that apply to this special pattern. You have to have even exponents, has to be subtraction. Feel free to write this in the top left corner. And you have to have all numbers have to be perfect squares. And if you can say yes to these 3 things, it's really easy to factor. You don't need to make a box. It's a special pattern that doesn't require a box. Now, when we wrote down our perfect squares, I did not include the smallest perfect square, which is 1. I'm going to go ahead and write the first 10 perfect squares. So 1, 4, 9, 16, 25, 36, 7 times 7 is 49, 8 times 8, 64, down to 100. All right, so these are our perfect squares. So let's make sure we're answering all of these questions. So first of all, you see we have an exponent. Is that exponent even? Yes. Is it subtraction? Yes. The number in front of x squared is 1. And then we have a 9. 1 and 9, do they appear in this list? So that means it's a pattern. No box needed. Make your 2 parentheses. In the front of the parentheses, you're going to put what multiplies to give you 1x squared. So what can I multiply to get 1x squared? 1x times 1x. You can even just put an x. And then what is the square root of 9? 3. Put that in the back. In this pattern, in order for this to work, they have to be conjugates, which is a fancy word, which means that the factors have to be opposite. So I'm going to put a plus in one and a minus in the other. So now it's factored. These are the factors. To find your solution, though, set each factor equal to 0. And you get x equals -3 and x equals +3. And that is question number 1. Try to do number 2 by yourself. So first, let's go ahead and ask ourselves our questions. Do we have even exponents? Yes. Do we have subtraction? Yep. We have a 1 and a 25. Are they in the list? Yep. So we can make our parentheses. X will go in the front. 5 goes in the back. And for this pattern, one is positive and the other one is negative. It doesn't matter which one you make positives. Like, you don't have to put plus first and the minus doesn't have to come second. So your solutions would be x equals 5. Well, x equals -5. And x equals +5. All right, try to do number 3. I'll go ahead and write it up here. For number 3 is 4x squared minus 49 equals 0. Go ahead and try to do that one. So we have subtraction, we have even exponents, and 4 is in this list, and so is 49. So we're going to make our 2 parentheses. So what will we multiply to get 4x squared? 2x times 2x, put that in the front, because 2x times 2x is 4x squared. And what multiplies to be 49? 7 times 7, that will go in the back. One has to be addition and the other one has to be subtraction. Alex, can you sit up for me, please? So now let's go ahead and set these both equal to 0. And leave your answer as a fraction. So we have 2 answers and they are both fractions. So we would get x equals, so you would subtract the 7. So 2x equals negative 7, then divide by 2. So x equals negative 7 over 2. And then we would add the 7 for the second equation. And then divide by 2. So x equals positive 7 over 2. And that would be your 2 solutions. Who had that for their 2 solutions for number 3? All right, good job. Let's look at question 4. Question 4, though, you need to set it equal to 0 first because you don't see that subtraction. So you want to start by setting it equal to 0 for question number 4. So that would become 64x squared minus 1 equals 0. So subtract that 1, set it equal to 0. Now go ahead and factor it down. And again, your answers are both going to be fractions. Okay, so we have our even exponent, we have subtraction, and 64 is a perfect square, and so is 1. So let's go ahead and make our parentheses. So 64x squared, 8x is going to go on the front, because that's how you get 64x squared, is 8x times 8x. And then what would multiply to be 1? The only thing that multiplies to be 1 is what? 1 times 1. Good job. Put a 1 in the back. 1 is addition, the other one is subtraction. So we have 8x plus 1 equals 0, 8x minus 1 equals 0. So for your first one, you're going to subtract the 1 and then divide by 8, which gives you negative 1/8. The second equation, you're going to add the 1 and divide by 8. So these would be your two solutions. All right, 2 more questions. Go ahead and flip it over. Let's look at question number 5. What's your first step? Now we don't have the special pattern anymore. So now we have to make our boxes. So take a minute, look at question number 5. What would be your first step for question number 5? Subtract the 12. Good job. So for number 5, after you subtract the 12, this is what you would have. Now you're going to look for a greatest common factor, something that we can take out of everything to make it easier to factor. Is there a number that we can take out? 2. Yep, let's divide every single number by 2. So that 2 comes to the front. X squared minus x minus 6. All right, so now you have A is 1, B is negative 1, and C is negative 6. So going back to what we learned yesterday, whenever A is 1, we can do a shortcut. Wait, what did you say, Chris? I didn't hear you. You didn't say anything? Okay. All right, so because A is 1, it has to be a positive 1. This A, the number in front of x squared, has to be positive 1. And it is, so we can do a shortcut. So we can put our 2 in the front, make your parentheses, put an x in front. So what we're doing is factoring this down. So I need 2 numbers that multiply to be A times C. So they multiply to A times C, which in this example will be 1 times negative 6. And they add to B. All right, so don't say it out loud, but see if you can figure out what those 2 numbers are. All right, anyone know what those numbers would be? Lex? -3, +2. So we can go directly to our factors, put a -3 and a +2. So now let's set both of these equal to 0. So if x minus 3 equals 0, that means our first solution is x equals 3. And then for our second factor, if x plus 2 equals 0, that means my second solution is x equals -2. All right, last question. See if you can do number 6 by yourself. So the 2, that's a really good question. So Deshaun asked, what about this 2? So this 2 is not going to affect the solution. Now it will change the vertex of the graph. So the graph is going to cross the x-axis at -2 and +3. So what that 2 is going to do is just make the vertex go, it's going to go down further before it comes back up. But it doesn't change where it crosses the x-axis. All right, try to do number 2 by your, number 6 is our last question. Try to do number 6 by yourself, set up the box, and then we'll work through it together. Yes. Sure. So for number 6, it's already set equal to 0. We don't have a greatest common factor, so A is 3, B is -4, and C is -4. So we do need to actually create a box. So to find our numbers, we need two numbers that multiply to be 3 times -4, and 3 times -4 is -12. So two numbers that multiply to be -12 and add to be -4. So that would be -6 and +2. All right, let's take out our GCFs. So for your top row, my greatest common factor is 3x. The bottom row or second row has a greatest common factor of +2. The first column has a greatest common factor of x. And the second column has a greatest common factor of -2. You can check it. 3x times x is 3x squared. 3x times -2 is -6x. X times 2 is 2x. And 2 times -2 is -4. So let's set each factor equal to 0, starting with this x minus 2. So your first solution is x equals 2. And then you take your second factor, 3x plus 2, set that equal to 0. Subtract 2. Divide by 3. And you would get -2/3. This is homework 18. Homework 18 is all factoring. It's the same as yesterday. It's not new. So use this time to work on your homework and get help, and enjoy your weekend.